All right, we're going to talk about multiplying and dividing rational expressions. So first, we should probably talk about what a rational expression is. A rational expression is anything that's written as a ratio, right? That's where the word rational comes from. So because variables in algebra often represent real numbers, operations with rational numbers and rational expressions are very similar. Just as with reducing fractions, to simplify a rational expression, you divide the numerator and denominator by their greatest common factor. So in all things that we do with rational expressions, we're always going to be looking to find the greatest common factor of the numerator and denominator, and then to divide that out. We always want to leave all rational expressions in the most simplified form possible. For example, here's a rational expression. We have 5x times x squared plus 4x plus 3 all over x minus 6 times x squared minus 9. The first step always is going to be, why is this not working? To factor. We need everything in factored form so that we can see what the least common factor of or the greatest common factor of the top and bottom will be. So the top, we're going to have the 5x. I'm going to factor that trinomial into two binomials, or at least I'm going to try. And the bottom is the same thing. X squared minus 9, hopefully you'll recognize that's a difference of squares, so we're going to factor that also. So let's start at the top. X squared plus 4x plus 3. That'd be x and x are factors of x squared. Factors of 3 that add up to 4 are 3 and 1, and they're both positive. Okay, then in the bottom we have x minus 3. X squared minus 9, that's going to be x plus 3 and x minus 3. Then I'm just going to look for all of my common factors, and I only see one in this case, and it's the x plus 3, right? So I'm going to take that out of the top and bottom, which leaves 5x times x plus 1 over x minus 6 times x minus 3. Depending on what the question says, we might leave it factored, or we might multiply it back through and make 5x squared plus 5x all over x squared minus 9x plus 18. These are the same thing, and depending on what the question asks, we might leave in one form or the other, but this has been simplified. One thing we have to watch out for, though, is the fact that the rational function is probably going to be undefined at certain points, right? Whenever we're talking about a fraction that has variables in it, we always have to watch out for the idea, or remember that we can't divide by 0, right? So here's the same question, but before I canceled anything, this is it in factored form. At which x values is the function undefined? Well, if I plug in a 6, this becomes 0, right? 6 minus 6 is 0. So if that is 0, when I multiply by x plus 3, I still get 0. And when I multiply 0 by x minus 3, I still get 0. So that would lead, plugging in a 6 would lead to this entire thing being 0, and then I'm dividing by 0. So x cannot equal 6. X also cannot equal negative 3, because that would make this guy 0. For the same reason, we'd end up dividing by 0. And x can also not be equal to positive 3 because of this third term. Right? So we got to look at every factor of the denominator and figure out, can this be 0? And if so, what x value makes it 0? And we have to exclude that x value. Okay, so this function cannot be defined at these 3 points. Even after we eliminate this guy, we still have to remember that it can't be a negative 3. And we'll talk more about that when we get to graphing these. So go ahead and pause this. Make sure you factor this as much as you can. And then take out any common factors, and make sure to list the values at which this expression is undefined. So pause the video and then come back. Okay. I'm going to change these to x's just because they're easier to write than z's. 2x times x plus 5 times, I'm going to factor this as I go. So x and x, factors of negative 8 that add up to 2. Factors of 8 are 1 and 8. 2 and 4. I'm seeing a 2 right there if I do a positive 4 and a negative 2. And then positive 4 times negative 2 gives me the negative 8, which is what we want. So that's good. All over x minus 1, x plus 5. Again, I'm just changing the z's to x's so it's easier to see. Okay. I've got an x plus 5 on top and an x plus 5 on the bottom, an x minus 2 on top, and an x minus 2 on the bottom. So this is the same as 2x times x plus 4 over x minus 1. X cannot equal 1, -5, or 2, because that will cause the expression to be undefined, right? Because we'll end up dividing by 0. So, for which values is this guy undefined? This is a standardized test example. You might see something like this on the ACT or the SAT. So I'm going to show you kind of how I would attack this question. The very first thing I'm going to see is this factor right here. In order to make that factor 0, x has to be 0, right? So x equaling 0 is a value where it's undefined. So that means it's got to be C or D. It can't be either of those two because they don't include 0. So then I just need to look at the factors of this. Well, there should be 2, right? Because this factors into 2 things. X. I don't even really need to know what they are, but I know that there shouldn't be 3 of them, right? It's going to turn out that they are 2 and 4, so it has to be C. But you could probably get there without actually doing anything on the question. So use some elimination strategies here. When you're solving or when you're tackling these multiple choice questions, do whatever you can to reduce the number of options before you even start doing any real math, or any computation, I should say. Sometimes we have to get a little bit creative about how we factor. So let's factor this all the way out, and you'll see what I mean. This first term right here, I can take a w out of, leaving me with 4w minus 3y, and then I'm going to have a w plus y at the end, all over 3y minus 4w times 5w plus y. Nothing in the bottom had a common factor. You'll see that 2 of these are very, very similar. 4w minus 3y and 3y minus 4w. The signs are just switched. So if I rewrite the bottom but with a -1 out front, I factor a -1 out of this, that can become -3y plus 4w, right? Or 4w plus 3, or sorry, minus 3y, which is the same as this guy. So we're going to do that. I'm going to factor a -1 out of that first term. Everything else will stay the same. But it's the only way to swap the signs of those two terms. Now, these two things are the same and they can come out, which leaves me with w times w plus y over 5w plus y, and we still have this -1, so I'm going to put it up top. You can put it in the bottom if you want to. We just have to make sure and accommodate for it. So this is simplified. Dividing this -1 out down here allowed us to make these two terms be the same. So sometimes you got to be a little creative with how you match things up. Anytime you see something that's the same but with opposite signs, you can factor a negative out in order to change the signs of both things. That may or may not come up in the homework. I can't remember if it's in the problems I included. The method that we use for multiplying and dividing fractions will still work with rational expressions, because rational expressions are just fractions. They just happen to contain variables. So to multiply, we just multiply straight across, right? We can factor out and reduce as we go, and we'll talk about that in a minute. Or we can do it at the end. But either way, we just multiply straight across. Numerators times numerators, denominators times denominators. Division, we're going to multiply by the reciprocal, right? Multiply by the reciprocal. It's technically called the multiplicative inverse, but we've called it the reciprocal more often. So let's just do one. I'm multiplying these two fractions, these two rational expressions. So the first thing I'm going to do, though, is look for common factors. I'm going to see diagonally where my common factors are first. So 6 over 5, c over d, this one's reduced. 15 over 8 is reduced, cd over a. So I can't do anything within each fraction, but I can start working diagonally. Like 6 and 8 are both divisible by 2. It leaves me with a 3 and a 4. 5 and 15 are both divisible by 5. It leaves me with a 1 and a 3. I've got a d on the bottom and 2 d's on the top, so I can take one of those out. That's going to leave me with 3c over 1 times 3cd over 4a. Notice I'm not canceling out these two c's because they're both in the numerator. They have to stay there. So then I just multiply straight across. 3c times 3cd is going to be 3 times 3, or 9. C times c, or c squared, and then a d, And then in the bottom, 1 times 4a is 4a, and that is reduced. I could have just multiplied straight from the get-go and then reduced. It just makes the numbers all bigger, and in my opinion, makes it a little bit more difficult. But if you want to multiply first and reduce later, you totally can. For b, we're dividing, so that means we need to multiply it by the inverse. So I'm going to copy this first one down, 7a squared b squared times, and here's where I flip it, 35a squared b over 12x squared y. Then I'm going to change colors just so you can see what I'm doing, and we're going to start factoring out like terms, or common factors, I should say. 18 and 12 are both divisible by 6. That leaves me with a 3 and a 2. I have an x in the top and 2 x's in the bottom, so that becomes x to the first. I have a y in the bottom and 3 y's up top, so that's going to become y squared. Okay, be careful when you start marking all over this, just so you can kind of see what you're left with. 7 goes into 35 5 times, but it only goes into 7 once. I have an a squared in the top and an a squared in the bottom. Those both cancel. A b in the top and a b squared in the bottom, so that's just b to the first. So what's left? 3. The x was gone. I've got y squared over 1b, right? The b squared is gone, but there's still a b. Notice I was careful to only cross out the exponent and not the entire variable. That's how I kept track of that. Times 5. A squared is gone, b is gone, over 2x. So when I multiply straight across, 3 times 5 is 15 y squared all over 2bx. The variables should go in alphabetical order. That is a heck of a lot simpler than that guy. Again, you could multiply straight across and then divide, but then you're multiplying 18 times 35, and then you have to try and factor that whole mess. So I think it's a lot easier to factor beforehand, before we multiply. We can do the same thing with polynomial rational expressions, right? We just have to factor them first. So let's factor everything. This is a great way to go back and practice our factoring. Like I told you then, it never goes away. Going to be used forever as long as you're taking math classes. So x and x. Factors of 16 that add up to 6. One's positive, one's negative. How about a negative 8 and a positive 2? Then down below, factors of 64 that add up to 16. 8 and 8. They're both going to be negative. X minus 8, x minus 8. That makes sense because 8 squared is 64. X and x. How about 2 and 3 when they're both positive? Okay, so now we're going to go back and start looking for common factors. So I've got x minus 8 over x minus 8. That's gone. I've got an x plus 2 and an x plus 2. That's gone. Here's an x minus 8 and an x minus 8. All that's left is this x plus 3 in the bottom. 1 over x plus 3. Isn't that a heck of a lot easier to look at than that whole thing? So again, factoring ahead of time, definitely the best way to go. Last but not least, this mess, right? So we got a complex fraction, fractions within fractions. So the very first thing I would do is rewrite it as a division problem. If you want to take this opportunity to change it to multiplication and you want to flip it the inverse at the same time, go ahead. If that seems like too much going on, then just write it as a division problem, and then you can change it to a multiplication problem. Whoops. Let's see. How do I fix this? Y plus 7 over y minus x. Okay, now we can look at this one and start factoring. So x squared minus y squared, that's a difference of squares. So that's x minus y times x plus y. And you can multiply that back through and you'll see that that middle term, the xy's, go away. Over y plus 7 times y minus 7. That's also a difference of squares. I've got a y plus 7 over a y minus x. Okay, here's where we're going to have to get a little bit creative again. Y plus 7, easy. I have a y minus x, which is very similar to x minus y, but it's not quite the same. So if I factor a -1 out, then I can change the sign of both of these, right? Because if I were to redistribute that -1, I'd be right back to where I started. So I'm just temporarily factoring out a -1. This becomes -x, positive y, which is exactly what's down here, positive y, negative x. So now I can cancel this part, not the -1. That guy has to stay. So what's left, I'm going to come over here to the left, is a -1 times x plus y over y minus 7 times, this whole thing is gone, right? So it's just times 1 over 1. So all I have is -x minus y over y minus 7. I distributed this -1 just to have it be gone. Okay? That's all. Go back through any of this that you might need to, and otherwise, good luck on the homework. Have a great day.